Hello students, today in your algebra class you're going to be working on negative and zero exponents. So before we begin, let's try these three quick warm-up problems. So in number one it says 2 to the third power, which hopefully you realize is 8. Negative 2 to the third power means negative 2 times negative 2 times negative 2, which is negative 8. The quantity of negative 2 to the third power is just like number 1 essentially, and it's 8. And number 4 is 2x. So when we have that, we have 2 divided by 1 divided by x. And when we do that, we flip and multiply, or copy dot flip. So it becomes 2 times x divided by 1, which is just 2x. Now, the purpose of this is that at the end of this lesson, you should be able to solve problems with negative and zero exponents. So let's go over a couple quick examples, or let's go over the properties and then we'll go over some examples. Now, for negative exponents, it says for every non-zero number a and integer n, a to the negative nth power equals 1 divided by a to the n. So in English, what it's saying is, anytime you have a negative exponent, you take the reciprocal of that number. So essentially, you're just moving it. So notice you have 6 to the negative fourth power. Notice that what you really have here is 6 to the negative fourth power divided by 1. And all we did here is we moved it. It started on the numerator, and because it had a negative exponent, we moved it down here, not changing anything else. So for negative 8 to the first power, so for the quantity of negative 8 to the negative first power, notice again, there is no fraction, so we're going to make one by dividing by 1. And because this negative 8 has a negative exponent, we move it from where it is. It was on the numerator, it's now going down to the denominator. For zero exponents, these are fairly easy. It basically says for every non-zero number a to the 0 equals 1. So in English, it's saying if we take any number or variable and we raise it to the 0 power, that's equal to 1. And we'll explain how that works in a little bit. So again, negative 2 to the 0 power equals 1. 1 and 2/100ths to the 0 power equals 1. And to overemphasize this even more, 1, 2, 3, 4, 5, 6, 7, 8, 9 to the 0 power equals 1. Hopefully you're getting the idea. So let's try a couple of quick practice problems on negative exponents. So to start, we have 6 squared divided by 6 to the 6th power. Now if we expand this, we get 6 times 6 divided by 6 times 6 times 6 times 6 times 6 times 6, 6 times. Now what will happen is, if we do this right, we can actually cancel these things out. So what we're left with here is 1 divided by 6 to the 4th power. So like we were saying, we would have 1 divided by 6 times 6 times 6 times 6, or 1 divided by 6 to the 4th power. If we use our division rules, and hopefully you would know that when we divide exponents with the same base, we subtract the top minus the bottom. So that would be 6 to the 2 minus 6th power, or 2nd minus 6th power, which would give you 6 to the negative 4th. Now remember, because this 6 is on the numerator of our fraction, and it has a negative exponent, it means that we take the reciprocal, or we move it. So it would go from 6 to the negative 4th power to 1 divided by 6 to the 4th power. So we didn't flip or take the reciprocal of the entire fraction, we just literally moved the 6 because that has a negative exponent. So example 2, x to the 3rd power divided by x to the 8th power is x times x times x divided by x times x 8 times. Now what will happen here is, again, we can simplify doing this the longer way, and we would get that all of the x's on the numerator would get canceled out, leaving us with a 1 divided by x to the 5th power, which is 1 divided by x to the 5th, or doing it the faster way, the top minus the bottom exponent, so x to the 3rd minus 8th power is x to the negative 5th, and again, because our x has a negative exponent, we are taking the reciprocal of that x, which is 1 divided by x to the negative 5th power. So we have two ways of writing it, one with a negative exponent and one without. Both are correct. So let's try example 1. Another example 1. This is for the zero exponent rule. And this should explain why anything raised to the 0 power equals 1. So we have x to the 6th divided by x to the 6th. And you'll notice that all of these things will get canceled out because we have equal number of x's on the numerator and denominator. So that's equal to 1 divided by 1, which is obviously just 1. If we use our division property, it's x to the 6th divided by x to the 6th. We subtract the exponents, top minus bottom. That's x to the 0 power. And because we see in this example that both equations start off the same, that means that x to the 0 and 1 are going to be exactly the same thing. So again, anything raised to the 0 power equals 1. So we're going to try again for the second example. And we have 10x to the 3rd divided by 5x to the 3rd. You'll see we expanded it again. And the x's cancel out. So what we have here is us breaking it down a little bit further for the 10. So 10 is 5 times 2, and 5 is obviously 5 times 1. What you'll realize here, x's cancel out, 5's cancel out, and you're really left with 2 times 1, which is 2 divided by 1, which is 2. And if we do it the much faster way, we're going to do this in small pieces. So 10 divided by 5 is 2. And when we divide exponents with the same base, we subtract top minus bottom. So 3 minus 3 is 0. So here's the part that tricks people sometimes. The 0 exponent is applied only to the x. Therefore, the x to the 0 power should be 1, and the 2 should be left alone. So what we're really looking at here is 2 times 1, which is 2. Now it's your turn. Try these 3 problems, write them down on your notes, and I'll see you guys tomorrow. That's all for now. Have a good one.